Hi everyone. I know it's the last session and we're all getting a bit tired, and so today we're going to talk about a pretty fun study, and I hope you can enjoy it. So my name is Jiaxin. I'm from School of Information at University of Michigan, and this is a joint work with Wang and Zhihan from Raw School of Business, and we're going to talk about grading bias. So we're starting from teacher grading. So we have all been like teachers and like GSIs and so we have done a lot of gradings in our life, right? And so I'm not sure if you know this guy. So his name is Israel Bell. So he was the president at Yale, and he implemented the first grading scale in Yale in the United States in like 1785. So it was like since then it becomes like very tedious and a lot of life-consuming task for all the teachers to give grades. And so grading is of course a challenging and tiring process because sometimes you need to grade like 100 assignments. We all have done that, right? And but also grades are very important for students because like it's just like everybody's caring about GPA, and for college admission and for job hunting is very important. So given it's like for teachers it's very tiring and challenging, but also for students it's very important. So how to ensure the grades are fair is a very tough to answer question. And grading is a classic sequential task. So by sequential task, you need to work on the same assignments repeatedly again and again and again. So when you just start for this, like the first several assignments, you're still energetic and happy to work on this. But later on, like you all now, it's like, okay, we're getting really tired of this. But in the meantime, you learn a lot of good stuff, right? You learn the patterns, like what are the typical mistakes in the student assignments. But when you're grading the maybe final 10 assignments, like seems like I'm getting really tired and I just want to think about what to eat this tonight. So grading is a sequential task, and we know that sequential tasks are having all kinds of sequential patterns. So in the specific setting of grading, is there any sequential bias? So that's our first research question. How are we going to answer that? We're using a unique data set combining circulating Canvas grading records from a large public university, as well as student administrative data covering 400,000 students from all the disciplines. And using this data, we build a fixed effect model using the grading order to predict a set of grading outcomes, including the standardized scores, because we know that different assignments and different subjects, they have very different scales. So we normalize those and we can make comparisons. We also study like two external text measures, including the common sentiment and common politeness, because we know that like the teachers can also directly give students textual feedback. And we control for along these student characteristics like their demographic information, their academic history, as well as the course characteristics. We control for a grader feedback because we know that some graders might be more generous, some graders can be stricter. So I don't know like whether you're a strict grader or not, but yeah, but we control for that using a grader feedback. And our the most important variable that we care about is the grading order and the grading outcomes. So let's get to the result you're asking. I know you're tired. So is there any sequential bias in grading? So in this plot, I'm going to show you some of the x-axis we're showing first is the reference group, is the first 10 graded assignment. It's like coded as a categorical variable. And then following we're showing is like the variable for every 10 summations. On the y-axis, since it's already normalized score, we're showing the change of scores in the number of standard deviations. So is there any sequential bias in grading? Let's take a look. So we show that for the following 10 to 20 assignments, there's a slight decrease in the scores that like comparing with the reference group, comparing with the first 10 graded assignment. But if we go further, we see that for later graded assignments, like if your assignment is graded way later, like from the 50s to 60s, the scores are way like worse than the first 10 graded assignments. So it just suggests that there's the later graded assignments are receiving way lower scores compared with earlier graded assignments. So there is a sequential bias in the grading. And does assignment comments also show a similar bias? Yes, we see that it's not just about the scores, it's also the comments, the feedback even to the student, like the sentiment as well as the politeness are also becoming more negative. Later graded assignments are receiving more negative sentiment as well as more implied comments. So here we already control for the score in this regression. We know that there can be a correlation between the sentiment and the scores, right? But the fact that we control for this and still seeing a similar pattern suggests that there might be some behavioral changes that like the graders are becoming more aggressive, like when they're getting tired for later graded assignments. And another top question we're trying to answer here is how can we measure the quality of grading? Because so far it can be like the teachers are just getting better at identifying mistakes, right? How can we evaluate the quality of grading at scale? So here we use two innovative measures. One is the variance of the grades, because we expect that for the graders, if their standard, if the quality is not changing, the standards are the same. The standard deviation should always be at the same level, right? If we're seeing different like variances, we can expect that, yeah, there might be some change of the standard in grade, but that's not good enough. So we use NLP to identify some students' complaints about the grades. So after the grades are posted, students are allowed to also comment back to the teacher, to the grades. And in the grades, in this kind of comment, students can also complain about the grades. So here are like real examples. For example, there are 12 sentences in this entry. I don't understand the points taken off, right? That's a complaint about the points taken off. There can be more direct regrade requests, like the only section I need an assignment on from not attending with JavaScript, please fix the grid. That's a very direct regrade request, suggests that there might be something wrong with the grid. So we use NLP to identify these complaints and regrade requests. So that's a more direct measure of this grading quality. So does the quality of grades change? Yes. So first, for the standard deviation, for the variance of grades, we see that there are way larger variances for later grade assignments, suggesting that the standard of grading are kind of changing a lot for later graded assignments. And similarly, for the regrade requests, we see that there are way more regrade requests for later graded assignments, suggesting that potentially the graders themselves are making more mistakes for later graded assignments, that the quality is actually dropping. So we do see that the quality grades are becoming worse for later graded assignments. So just to summarize, is there any sequential bias in grading? Yes. We see that assignments graded later in the sequence are receiving lower scores, receiving more negative comments and less applied comments, and the later grades are having lower quality, as suggested by the variance of grades as well as student regrade requests. So let's get back to this guy. So the sequential bias in grading might have been there for centuries, right? Because that's a behavioral level bias. But the effect is minimal as students are randomly affected by this bias. Sometimes my assignments are graded later, sometimes your assignments are graded later, and later on, like all the results, like all the effect will be evened out. But there's one thing that fundamentally changed the story here, are the learning management system. Like now we're all using learning management systems like Canvas, like Blackboard, and all these platforms are sorting student assignments, are pre-ordering student assignments based on student surnames. What does that mean? So this is the real data, is a correlation between the grading order and surname order. So in our data, we show that most of the assignments are graded in the surname order. The correlation between the grading order and the student names are larger than 0.8. So most of the assignments are graded in the surname order, and only a small portion, although like some graders might be going into random entries and doing that in a quasi-random order, and some like only around like 20% of assignments are graded in a quasi-random order. So let's formalize this. So this before the learning management system are largely deployed in our society, most of the assignments are graded in a random order. There's no correlation between the grading order and student surnames. But now with the learning management system, most of the assignments are graded in a surname order, so there's a strong correlation between the surname order as well as the grading order. So what's the immediate difference? So this is also based on the real data in our real scores from our data, that for randomly graded assignments, the average grading order for students with different initials will all be almost the same. They will have like the same level of average grading order for all the assignments, like for students with different initials. But if your assignments are graded in a surname order, like earlier initial students are more likely to receive earlier grades, and later initial students are consistently receiving later grades, and for all their assignments during their like study, like in college, in undergrad, in high schools, as long as the school is using learning mechanisms. And so there's a large grading order gap for students with different initials because of this design. So our follow-up research question is, does the design of the grading system transform the sequential bias into an initial disparity? And we use a similar fixed effect model that trying to predict the grading outcomes as standard scores, a common sentiment, common blindness, and we control for a long list of student characteristics, as well as the course characteristics and the greater fixed effect. And the main variable we care about here is the grading mode, the interaction between the grading mode and the student initials. And here we're trying to predict like a list of grading outcomes. So does the grading system convert the sequential bias into initial disparity? On the x-axis, we're showing the students in different initial groups, like from A to E to B to Z. And on the y-axis, again, since it's a normalized score, we're showing the change of grades when student assignments are graded by the initial order. So it's basically compared with the random grading setting. That's kind of like our control group. So we showed that actually for the earlier initial students, since in this setting, if your assignments are graded in a surname order, their average grading order will be way earlier than the random group. So they're actually benefiting from this design that their scores tend to be higher than the random grading group. But later on, for middle initial students, we see there's not a very significant result, especially for students in F to G, because their average grading order does not change a lot into grading modes. But for later initial students, like students in P to T and U to Z, since your average grading order are way later in the surname grading order groups, they're receiving way worse scores comparing in the random grading setting. So yes, we do see that later initial students are receiving relatively lower grades if their assignments are graded in surname order. And a similar bias is persistent in grading comments as well as the regrade requests, that later initial students are receiving more negative comments as well as are more likely to submit regrade requests. So yeah, just to summarize that, we see that later initial students are receiving relatively lower scores because of this design, because of all the learning management systems are sorting students' assignments based on their surnames. But this is not good enough. Since things like this is still not a causal claim. So how are we going to make a causal claim without that? And we notice that in our setting, in our data, there's actually a very interesting setup that there are graders not like the unconventional graders or creative that are not following the design. They're not going the order from A to Z. There are some small subset graders going backwards from D to A. So it can be like sometimes I'm tired of this grading order, I go back from D to A. I do that sometimes. And so if it is really the design of the system, like sorting based on student surnames, that is leading to this disparity, then we should expect that in this reverse grading order, the effect will also be reversed accordingly. So will the effect be reversed accordingly? Yes, we see that in this setting, it is actually the later initial students getting more benefit because their assignments are graded earlier in this reverse grading setting. And now, like the earlier initial students are more negatively affected by this design. So yes, we do see that it is the system design that lead to the initial disparity in grading because they're pre-ordering student assignments based on surnames. And this pattern is generally consistent across for the subject, especially on the upper column is showing the sequential bias, generally consistent across subject. For the initial disparity, we show that there are way larger effects in the social science and humanity areas compared with the engineering and medical and science areas, potentially because those assignments are more, it takes a lot longer time to grade, and those are more subjective aspects. So how serious is the problem? So let's do that. Look back to this plot again. Now we'll only show the standard deviation. Like we can actually convert that standard deviation into a 100-point scale. So the grades that later initial students receive are 0.6 per 100 points lower than earlier initial students. So that seems to be like the absolute score seems to be small. But if you consider the calls from the government and the calls from students they need to make to improve their test scores by this margin, it's actually pretty large. For example, like the state government need to spend $1,000 like for each student to improve their test scores by around 0.15 standard deviations. And also for a student need to spend like actual 2 hours per week on their task, on their homework to improve their scores by this margin. And if you consider that all the learning management systems are adopting this design, which can potentially affect 15 million students around the world. So the societal cost because of this design will actually be pretty large. And we argue that like for all the learning management systems, the fee can be very simple, right? It can just like be randomizing students' assignments instead of sorting them based on student surenames. But as scholars, there can be more complicated solutions for the sequential bias because we know that's the root cause of like the of this pattern. That, for example, we can maybe design behavioral nudges on graders. We can design better fair and sorting algorithms to pre-order student assignments, and maybe design some new AI assistant to help the graders with better grade and help when they're getting fatigue. And this is everything about our result. And I'm currently on the job market paper. I'm currently on the job market, and yeah. So I study human-centered AI and NLP and fairness and digital platforms. So if your school is hiring, I'm happy to have a chat. And yes, thanks a lot for listening.
Very great talk, I think. Every one of us is essentially affected. Any questions?